Hello and welcome. This tutorial will guide you through performing backup and restore operations using OADP backup and restore in the Cloud Pak for integration. Before we dive in, let's walk through the key steps so you know what to expect. Step 1. Install the OADP operator. We will install the OpenShift API for data protection operator from the software catalog. This operator deploys Valero on your cluster, which is the engine that handles all the backup and restore operations. Step 2. Configure the cloud storage credentials. We will create a Kubernetes secret containing the credentials that allow OADP to read and write backups to external object storage. Step 3. Create the data protection application. This is the core OADP configuration object. It tells Valero where to store backups, which plugins to load, and how to run. Step 4. Label your CP4I resources. OADP only backs up resources that carry a specific backup label. We will apply labels to the catalog sources, subscriptions, operator groups, namespace, and product instances we want to include. Step 5. Run the backup. Once everything is labeled, we'll create a backup instance and confirm it completes successfully. Step 6. Restore from backup. To simulate a real disaster recovery scenario, we will delete the namespace entirely and then restore it from the backup we just created, verifying that all operators and instances come back up successfully. This tutorial follows the IBM documentation for backing up and restoring Cloud Pak for integration, which you can find in the IBM docs. A link is included below this video. Let's get started. In this tutorial, we'll cover a namespace code backup and restore scenario. This is my OpenShift cluster. I'm logged in as a kube admin and I have created a namespace called nav-ns. I have also installed the CP4I point products in this namespace. Next, I'm going to install OpenShift API for data protection operator. This operator installs Valero on OpenShift container platform cluster, allowing users to back up and restore applications. To install it, I'll go to the software catalog and search for OADP operator. We will install the latest stable version in the recommended namespace OpenShift-ADP. If this namespace does not already exist, it will be created automatically during the operator installation. After clicking install, we will wait for the installation to complete. The operator has been installed successfully. Under All Instances tab, you will be able to see your OADP related instances after they have been created. Next, using the button in the top right corner, I'll create a secret in the OpenShift namespace for cloud storage credentials. OADP uses external storage to back up OpenShift and Kubernetes resources as well as persistent volume data. This secret provides the required permission for OADP to write backups to that storage and read from it during restore operations. Next, I need to set up a data protection application instance. The data protection application is the main OADP configuration object. The secret only stores the storage credentials that we created earlier. While this YAML tells OADP and Valero how to run, where to store backups, and which plugins or features to load, you can create a data protection application by clicking Create Instance directly within the OADP operator in the OpenShift console. In this case, I am using an existing data protection application YAML that I use for demos. The file is available in public GitHub repository. The link is included in the description below. I have now created the data protection application instance. Once this is created, the backup storage location also becomes available. The backup storage location object is the Valero resource that represents the backup destination where your backup data will be stored. Now I'll start the backup steps. For the full list of prerequisites, please refer to the IBM documentation. The backup process includes resources that have appropriate backup label. This means you must ensure that every resource you want to back up has the required label applied. Next, I will label the resources I want to include in the backup. I'll start by labeling the catalog sources. In my case, they are all located in the OpenShift Marketplace namespace. You may notice a not found error for the event streams catalog source. This is expected in my environment because event streams catalog source is not present on my cluster and the event streams is not installed. Next, I'll label the subscription that are part of the CP4I. Once the subscriptions have been labeled, I'll label the nav-ns namespace where CP4I is installed. Next, I will label the operator groups. The step is only required if your CP4I installation is deployed into a specific namespace as shown in this example. Now I need to label the instances of the CP4I products installed in the nav-ns namespace. Once all the resources are labeled, I need to add a couple of additional labels to the queue manager instance. You only need to label the queue managers that you created manually. Queue managers that are owned by assemblies or messaging servers should not be labeled directly, as they will be restored by their owning resource. You must also label any config maps and secrets that are used to configure the queue managers. After this, I will label the IBM entitlement key secret. We need this secret to pull images at restore time. Once that is complete, I'll create a backup instance. In this example, I have named it Hassan Backup 3. The backup is now in progress. I'll run this command to check the status of the backup. As you can see, the backup is currently still in progress. For the purpose of this tutorial, after the backup completed, I deleted the nav-ns namespace from my cluster so that it could be restored from scratch. As you can see, the nav-ns namespace no longer exists on this cluster. Now I will start the restore process. I'll create a restore YAML and use the name Hassan Backup 3 Restore. Under the spec section, you can see that the backup name is set to Hassan Backup 3. We will use this backup to perform the restore. The restore is now in progress. The nav-ns namespace has been recreated. The operators are now installed, and the operators are either up and running or in process of being restored. The restore has completed successfully. Thank you for watching this tutorial. We have covered a namespace scope backup and restore scenario using OADP backup and restore on an OpenShift cluster. I hope you found this tutorial useful. Thank you for watching.